All right, chapter 8, section 1, similar polygons. Keep in mind the word similar is different than congruent, and there is a symbol for this. Please do not get mixed up and say it is congruent. So just showing you the symbol for similar is just the squiggly sign, okay? Congruent had the equal sign underneath. This is not congruent. We are talking about similar polygons. So just a little startup. All right. Corresponding parts of similar polygons. We've dealt with corresponding parts. They're kind of like in relations to. So they're almost in they're going to be in, I want to say like the same position looking on two diagrams. So when I'm looking at this, super important, we need to know corresponding angles are always congruent. That is something that we should know. Corresponding angles are congruent. But the corresponding sides are proportional. So we're dealing with some sort of ratio or proportion, okay? Keep in mind we're dealing with similar, not congruent. So this only applies to when you have similar polygons. So when I'm looking at this diagram, it's kind of giving me information that I need to know. So my angles, angle A and angle M, are going to be equal. Your angles are going to be congruent. Then I have B and N. Okay, so B and N are going to be the same angle measure. So I'm kind of just drawing them on here for you. And then I'm going to have, let's get another color. I'm going to have C and O. Okay, C and O are going to be the same angle measure. And they're going to be the same angle measure. And then lastly, I'm going to have D and P. Okay, so my angles are congruent. And then my sides are proportional. So now I'm dealing with my sides. So looking at my sides, they're going to be proportional. What do I mean by that? I'm going to give you side measurements. I have 6, 8, 8 and 10, and then I have 3, 4, 4, and 5. So when I'm looking at this proportions, I'm going to write a proportion. So AB over MN, I have 6 over 3, which gives me 2 over 1. Same thing for the other side. Let's say I have 8 over 4, 2 over 1. Keep in mind I'm still following that pattern of my left image over my right image for my proportion. And then 10 over 5, which is going to give me 2 over 1. Kind of giving you some information for the next slide. If they're asking me for scale factor, okay? So if I'm trying to find my scale factor, I'm going to go from my measurement of my side on my right diagram to the measurement of my side on my left diagram. So look, I'm putting it as 3 over 6. 3 over 6 simplifies to 1 over 2. That is my scale factor. When I'm looking at this diagram, I'm going from this diagram to my smaller one. It's getting smaller, correct? So that means my scale factor is half. Okay, so what does that mean? If I were to multiply all of my sides by a half, it's going to give me my measurement over here. So that is my scale factor. I did not have to use only 3 and 6. I could have used 4 over 8. It's still, again, going to give me the same 1 over 2. And again, I could also use 5 over 10, which gives me my scale factor of 1 over 2. So I'm still gonna, doesn't matter what I use as long as it's the corresponding side, okay? So my scale factor is the simplified number, okay? It has to be simplified, so my scale factor would be 1 over 2. All right, now we're at scale factor. So scale factor, you have to simplify your ratio. So scale factor is a simplified ratio. Okay, always going to be that simplified ratio. Keep in mind you could only take a scale factor If your polygons are similar, and if you forgot this symbol for similar is just the squiggly line, okay? Ratio of corresponding sides of two similar polygons. So I'm trying to find my scale factor here. It's the ratio of my corresponding sides. So when I'm looking at this, depending on how they're giving me that information, if I'm looking at these triangles, they are going to be similar. All my angles are the same, but my side measures are not. So when I'm looking at it, like I said, first scale factor, I'm going from my right diagram on top of my left. So it doesn't matter the side because they're all equal. I'm going to do 6/3, which simplifies to 2/1, which is just 2 as a whole. So my scale factor is going to be 2. Keep in mind again, if I multiply this diagram by 2, all of my measurements are going to be 2 times larger. All right, looking at the first example, it says find the scale factor of A, B, C, D to M, N, O, P. So if I'm looking at these two diagrams, I see they're only giving me the measurement of this side. Okay, so I'm just going to go ahead and highlight my corresponding sides. My corresponding sides, I'm going to have, let's do this color. I'm going to have AB is corresponding with MN. And then I have BC is corresponding to NO. I have DC is corresponding to PO. And lastly, I'm going to have AD is corresponding with MP. So now I'm going to go ahead and find my scale factor. Again, I'm using my right diagram to my left diagram. So I'm going to take it as 8/10, which simplifies to what? As simple as it can be. What would I get? Good, 4/5. 4/5. I'm going to do 8 over my 10. So now this right here is my scale factor. Okay, next question. Find X, Y, and Z. So in order for me to find that, I'm going to I'm using my scale factor, X, Y, and Z. So how am I going to use it? I'm solving for something that's missing. Remember, they're all similar. So what do I mean by that? I'm going to take my 4/5, and I'm going to go ahead and solve for my y first. So looking at it, again, I'm doing my right diagram, which is y, over 12. Next, I'm going to go ahead and cross multiply to solve for y. So cross multiplying, you're going to get 5y equals multiplying them together, 48. And then dividing by 5. So after you divide by 5, you're going to get y, which is 9 and 3/5. I would keep it as a fraction. If you want to change it to a decimal, always round to the nearest tenth. So writing my answer in, 9 and 3/5. So I'm going to go ahead and do the same thing for x. So taking what I have, which is my ratio, 4/5, equals, I'm going to have x over 4. Again, same thing as before, cross multiply and divide. Cross multiplying, I'm going to get 5x equals 16, divide both sides by 5. And then I'm going to get x equals 3 1/5. And that's my answer for x. X is 3 1/5. And lastly, I'm going to go ahead and do the same thing for z. So z, I'm going to go ahead and take again my scale factor, which what I had was 4/5. Set it equal to z over 14. and then cross multiply and divide like I did for the other ones. So I'm going to get 5z equals 56. Divide both sides by 5. And z equals 11 and 1/5. Again, if you want to change it to decimal, make sure you round them to the nearest 10th. And I believe it's the same thing on your big ideas homework. So round to the nearest 10th. All right, next thing they ask is find the perimeter for each. So this should be pretty easy. All you have to do for this is add all of your sides. So 10 plus 12 plus 4 plus 14. If you added them correctly, your answer should have been 40 units. And luckily for this one, they all have the same denominator, so it should be pretty easy to add these. So 9 and 3/5 plus 3 and 1/5 and 11 and 1/5. Adding the fractions gives you a whole. And then you're going to have 10, 20, 21, 24, and then perimeter equals 30, not 38, just kidding, 32 units. And that's how you're finding perimeter. Next question, they're asking, find the ratio of the perimeters. So I'm going to go ahead and take my perimeters, and I'm setting them up as a ratio. So same thing as I did before, I'm going to put my right ratio, or my right perimeter over my left. And I'm simplifying using 8. And I'm going to get 4/5. So if you're looking at it, my perimeter ratio is the same ratio as my scale factor. All right, corresponding lengths in similar polygons. I'm going to go ahead and read this one for you. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygon. So again, if two polygons are similar, then the ratio of two corresponding side lengths. So the ratio of the two corresponding side lengths is equal to the scale factor. So the side lengths are equal to the scale factor. So again, the corresponding side lengths is equal to the scale factor. All right, so looking at this example, it says in the diagram, triangle TPR is similar to triangle XPZ. Find the length of the altitude for PS. So if we're not sure what the altitude is, we kind of covered that last semester. This is my altitude highlighted in yellow. And I need to find the altitude. So first I'm going to have to find the scale factor. Okay, keep in mind with scale factor, it's the measure of the side length, the entire side length. So I'm going to use two different colors for this one just so you could see where I'm getting it. Right now I have XZ, and then I also have, let's do this one in pink, TR. So finding my side lengths, finding my ratios. I'm just going to write the letters. I have XZ over TR. So I have my orange over my pink. Think of them as two diagrams, my right one and my left one. And now I'm going to go ahead and add them. 8 and 8 is 16 over 12. Okay, so I have 16 over 12, and that could be simplified to what? What could I simplify this to? What was that? I think someone said it. Good, 4 over 3. So right now, what did I just find? This is considered my scale factor. So again, I'm still following that pattern, orange over pink. And then I'm going to use that scale factor. Okay, use scale factor. And I'm going to take that 4 over 3 and I'm setting it equal to, again, I'm taking this orange side. I'm going to have 20. Okay, because I took it from this measurement over I don't know what my altitude is. So same thing as before. We're going to do the same process. I'm going to cross multiply, and then I'm going to divide. So cross multiplying, I'm going to get 4x equals 60, and then divide. Cross multiply, divide, x is going to equal 15. So PS, which is my altitude, equals 15. And I'm done. Questions on example number 2. All right, perimeter of similar polygons. If two polygons are similar, then the ratio of their perimeter is equal to the ratio of their corresponding side lengths. So again, you have these words is equal to. Think of that as your base words. So I'm going to read it again. It says, if two polygons are similar, then the ratio of their perimeter is equal to the ratio of their corresponding side lengths. So again, we did this one in the previous slides. The perimeter measure is going to be equal to the side lengths. So here are the ratios of my side lengths. This is my perimeter right here, and they are equal to each other. Okay, doesn't matter which side lengths I'm using. The ratio of the side lengths is equal to the ratio of the perimeter. All right, areas of similar polygons. Please do not forget this one. A lot of people mess up on the area. Whenever you're finding the area of something, it is always squared. So pay attention to this one. It says, if two polygons are similar, the ratio of their area, okay, so just the ratio of the area is equal to the squares of the ratios of their corresponding side lengths. Keep in mind, keyword here is square. You're squaring it. Okay, so when I'm looking at this, everything is going to be squared. Only thing that's going to be squared is your side lengths, not your area. You're taking the area, the regular area, whatever measurement they're giving you for area is equal to the side lengths squared, the corresponding side length squared. So if you look at the next slide, we're going to go ahead and do that example. Don't forget that for area. All right, looking at this example in the diagram, GH, J and K, is similar to L, M, and P. So they're telling me that the polygons are similar. Now they want me to find the area of L, M, and P. Okay, so they're giving me the side lengths of one corresponding side. Okay, one pair of corresponding sides. But they are giving me the area of this small rectangle. So the area for this right here is 84 meters squared. So first thing I have to do is find the side lengths, and I'm going to simplify them. So when I'm looking at this, I have two triangles. Let's just say that this one is my orange one. That's the area I'm trying to find for my larger one. So looking at it, I'm going to have, again, right to left, I'm going to do 21 over 7. Keep in mind they're asking for area, so it has to be squared. 21 and 7. Can I simplify 21 over 7? Yes, I can. I'm going to simplify it to 3 over 1 squared. Keep in mind I have not solved anything yet. I just found my ratio of my side lengths. So now that ratio of my corresponding side lengths is equal to the area. So again, I'm going to take that information. Here's the ratio of my side lengths. 3 over 1 squared, keep in mind it is squared, is equal to the area of the polygon. Do I know my larger one? No, I do not. So I'm going to represent that one as x. Do I know the area of my smaller one? Yes, I do. I'm going to go ahead and write it in, which is 84. So going ahead, I have 84. So first, I'm going to go ahead and distribute that square. Keep in mind it's outside of my parentheses. So let's say if I had a number on the bottom, yes, I'm going to square the bottom number as well. So this one, I don't have to square the bottom number because it's just a 1. But 3 squared is going to give me 9 over 1. Making it a little thicker. I'm going to get 9 over 1 equals x over 84. And same thing as I did before, cross multiply and divide. So I'm still following that same pattern. Yes, you are going to get a larger number. However, don't forget you will have a calculator. So I have x equals, if you multiplied it correctly, I'm going to solve it for you. It's going to be 756 meters squared. So my answer for this, for my area, again, area is always squared, 756 meters squared. Do we have any questions on this one? Questions, comments, concerns? All right, homework for this is on big ideas due tomorrow morning.